Hi, my name is Ed Blomdahl, and today I'm going to talk about the photon and exactly what the photon is and maybe what it isn't. The topic title of the day is The True Story of the Photon, because what is out there now, mass, rest mass, approaching the speed of light, and there's certain questions, there's contradictions, inconsistencies that I think need to be discussed. This is also the time during the coronavirus, and things are different, a little more difficult for people. We have to improvise in certain ways. And I do hope that everybody that watches this or sees this is doing well until we can get past this coronavirus. So we go on. The genesis of this talk, which I have papers basically written for all my talks, but is that when I was first reading the literature, and they talked about the photon, and then they talked about the energy of the photon. And what confused me to a certain degree was the fact that when they list the energy of a photon, it's just the E for energy equals hc divided by lambda. H is the Planck constant, c is the speed of light, and lambda is the wavelength of whatever type of light that you're looking at. This work that I've done only pertains to the visible light spectrum. I have not looked at the radio waves. I have not looked at X-rays. I haven't gone that far. Maybe other people want to do that, but I'm not going to go touch that today. So what happens with the Planck constant is, or another way to write it is just hc over lambda is F equals c over lambda, and there's different ways to show the symbols. So if we look at this, Planck's constant equals 6.26 e to the negative 34, or 10 to the negative 34, Js, joules second. And joules are a function of equal kilograms metered squared divided by s squared. It's a little rough there, but so that's second squared. But if a photon, as they tell us, or as science thinks now, is massless, then I always thought, what are you doing with kilograms? If it has no mass, how can you have being a function of mass? And so Planck's constant is a function of joules, but joules itself has a function of mass. So that doesn't really make too much sense. But sometimes they show it as momentum. Well, you can do the momentum as well. It's just h over lambda, but you end up with h, and h is a function of joules, which is a function of kilograms, which is a mass. There's no getting around it. I mean, you can say rest mass. I'm not sure that has too much value to it. But, for me, this was like I said before, it was an inconsistency, and it didn't make sense to me, so I just wanted to try and dig into it a little bit and see what was really going on. So if a photon is massless, then how can it be a function of mass? And I think this even pertains to something like a supposed black hole, right, where light can't escape. But how is the black hole able to bring light in, have it disappear, or the event horizon, go around the event horizon, if light itself doesn't have any mass? Okay, that's a strange one. That makes no sense to me. To me, it's somewhat like, if I was thinking of an analogy, it would be like having a magnet, a relatively powerful magnet, a bar magnet, a horseshoe magnet, and it would be a cotton ball. And you put the two down together, hoping that the magnet will attract the cotton ball. That's not going to happen. This isn't going to happen. I don't, there's reason for why they did it, but I don't think they're very good reasons. I actually asked some people, physicists, astrophysicists, astronomers, what's going on and, why would they think this? And this is what one woman astronomer said to me. Sometimes, with regards to this problem, sometimes it is wise to ignore the units. So her basic idea is, let's pretend the problem doesn't exist. Hopefully we can just work without it. That's not science. I won't characterize what it is to me, but as far as I know, that's not science. The same thing is like going to buy a car. The car is a function of the transmission, the tires and the wheels, the engine, the windshield, and then on the sticker they have gold. Well, the car doesn't have gold in it. You can't say the car is a function of gold, right? It doesn't make any sense. Same thing with this. The logic says it doesn't make any sense. Something's wrong. So, but what I did find out was that, through the reading the literature and just thinking about it, is that one of the reasons why you can't have mass and a photon is because it will break down Mr. Einstein's special theory of relativity. In other words, I did a paper, but I did an earlier YouTube video in which I sort of take apart the special theory. I'll get to the title later, but one problem is the Lorentz factor. Right? The problem is if you have a photon and it has mass going at the speed of light, the Lorentz factor breaks down. And since the whole of Einstein's special theory is based around the Lorentz factor, the whole theory basically falls apart. And that's my point of what I was trying to make. Just to let you know, it's listed under my name, Edward A. Blomdahl, which is down here. And it's called Breaking the Light Barrier, Adding Velocities Beyond the Speed of Light. Just as a side note, Maxwell never stated that you can't add the speed of light with the motion of its source. James Clerk Maxwell. That was Einstein. That was Einstein in the late 19th century, early 20th century, but I think he got it wrong. But anyway, we go on. So, Gmail, my account, my email address is blomdahl300@gmail.com. If you have questions or you want to make a comment or whatever, that'd be fine. All right, so what do we do? This is how we changed screens in the olden days. Get another whiteboard. Okay. So again, that set me off looking at the literature, just reading papers, looking at books, learning how to get my hand on. And I came across the de Broglie wavelength. De Broglie was sort of at the heart of the 20th century quantum mechanics and so forth. And he came up with the de Broglie wavelength, which is simple. It's just the lambda for the wavelength, again, h, Planck's constant, and mv, mass times velocity. So that's a pretty easy equation. But I said, all right, well, maybe I can use that. Instead of v, if I wanted to use that for light, then I'd have to replace it with the speed of light. The speed of light is c. So by letting v equal c and solving for m, right, you end up with this little equation over here. The mass in kilograms is equal to h divided by lambda times c. Sometimes you'll see this written as rho for momentum, mv, which it is. I just want to break out the mass, which is what I do. So it's basically a three-part equation. So I looked at this and I said, well, what am I going to do? Okay. So as I said, I'm just looking at the visible light spectrum at this point. I haven't gone beyond that. I was looking at the visible light spectrum. So I started with red, which I think is probably the easiest. And I just said, okay, if I set lambda equals 700 nanometers, the speed of light is simply 2.99792 e to the eighth. And red, just basically plug into the numbers, and you get red equals 3.1571 e to the negative 36 kilograms. It doesn't sound unreasonable. It doesn't sound unreasonable to have that for a mass. You know, one thing, well, let me get through the other ones first. And I did this for all the others. I did it for orange. I mean, if you can see here, you know, what the numbers are, I just basically used this formula, put in a wavelength, C is known, and you have H, and this is the numbers you get. So for nanometers for orange, I used 590. For nanometers for, must be yellow, I used 570. For nanometers for green, 540. For nanometers for blue, 475. And for nanometers of violet, I used 415. So, I mean, it's going to change depending on the nanometers that you use here, but that's sort of the ballpark area of, you know, what I think is a close value to what a photon is. The other thing is that it shows that the higher frequencies, like blue, the larger the mass, right? So, and that makes sense, because if you're looking at a prism and you shine light through a prism, and as the light is dispersed into the different colors, red, of course, is a very flat trajectory. Blue is a more bending trajectory. As other people have suggested, some of that might be that the blue being larger has some type of congestion to it. In other words, they're larger as they hit the prism. They just back up a little bit. I've never measured, I don't know, but I think that's sort of this is what the physics show, right? The other thing is, the smaller the mass, the less the congestion. So that's something for like white. I'm sorry, something like red, right? It has lower frequencies, so the red can basically go through the prism more easily than can something like blue or violet, which has a greater deflection. So, I mean, and that's not unusual either, because there's not the congestion factor